In 11.2e, we're going to show that a two-sample z-test for comparing the difference of two proportions and the chi-square test for a 2x2 two-way table actually give you similar results. And let's look at this, ibuprofen versus acetaminophen. In a study reported by this emergency medicine, researchers conducted a randomized, double-blind clinical trial to compare the effects of ibuprofen and acetaminophen plus codeine as a pain reliever for children recovering from arm fractures. There were many response variables, including the presence of any adverse effects such as nausea, dizziness, and drowsiness. Here are the results. So we do have a two-way table where we're looking at ibuprofen, or the treatment, and the actual effects of that. So in Part A, explain why is it important to investigate this question with a randomized double-blind clinical trial. It's a great Chapter 4 question. There's actually three things we could state. One of the reasons why it's important is we actually want treatments in an experiment to be randomly assigned, so the two treatment groups are roughly equivalent at the beginning of the study. Another thing is the effects of lurking variables should be balanced out among the two groups because of the randomization. And that's good. The best way for us to control for the lurking variables, because of the children are all different, is to have that randomization process for our experiment. And the third thing, it's also important that both the patient and those administering the drugs and measuring the response do not know who's receiving which treatment. This will keep the expectations the same for both groups of patients and not favor one treatment over the other. If you can do a double-blind experiment, it really is your best bet, trying to eliminate any type of bias that the person giving the medicine may have or reactions they may have to the actual subjects. Part B wants to know, is the difference between the two groups statistically significant? Let's conduct an appropriate chi-square test to find out. Then we'll come back and actually do the differences of two proportions. So for chi-squared, we're going to do a hypothesis test and use alpha of 0.05. Our null hypothesis is there's no difference in the proportion of patients who suffer adverse effects taking ibuprofen or acetaminophen. But our alternative is there is a difference in the proportion of patients who suffer the actual effects. We are going to do a chi-square test of homogeneity because this is two samples, but it's one variable we're measuring. We're measuring the treatments, but we have our two samples, those getting the ibuprofen and those with the acetaminophen. So for the plan, randomness, the treatments are randomly assigned, so we're fine. In terms of our large sample size, the expected counts are all greater than 5. Remember, we could have calculated this. For example, to get the 48.5, I would do 93 times 122 over 234, or run the test and look at matrix B in my calculator. For independence, knowing one subject has had adverse effects shouldn't give any additional information about the responses of the other subjects, so the observations can be considered independent. Again, this is an experiment. We do not check the 10% condition. We just know that the experiment was set up to ensure we would have our independence. So we state it accordingly. For the due portion, our test statistic, which we can actually get from the calculator, is 11.15. The degrees of freedom we need to use is 2 minus 1 times 2 minus 1. So we have 1 degree of freedom. To get the p-value, we're going to do our chi-squared CDF of 11.15 up to a really large number, 1 degree of freedom. It's a very small p-value. Based on that, we can make our conclusion and say that the p-value is less than 0.05. It's 0 is less than 0.05 really. Therefore, we reject H sub A. And we have convincing evidence that there is a difference in the proportions of patients, like those who suffer adverse effects when taking ibuprofen or acetaminophen with codeine. Now, I'm going to show you that if you did a two-sample difference in proportions test, that you're actually going to get the exact same result. Let's take a look at that. To set up the hypothesis, remember, we're comparing the proportion of subjects with adverse effects to just 2 treatments. Because it's just 2 treatments, that's why we can do this. If it was 3 or 4 treatments, we could only do the chi-square test of homogeneity. So we're going to set up our hypothesis that P sub I minus P sub A equals 0. So ibuprofen minus acetaminophen. We think the difference is 0. But we really think it is different. So this is really a two-sided test. I'm going to use the technology to actually run this. And I will tell you if we do in terms of the test we would run, I'm going to write it down as a two-sample z-test for p of I minus p of a, so the difference in my proportions. If you run this test on the calculator, do the stat test and choose this, type in the data appropriately, you are going to find that the z-score is negative 3.33 and the p-value is exactly what we computed for our chi-square test of homogeneity. Based on this, we're going to make the exact same conclusions, and we're going to say because the p-value is less than 0.05, we reject this and we conclude that there is a difference between the proportion of the test people based on this medicine. Now, if you want to see by hand again as a nice recollection, recall the formula. The test statistic for the difference of two proportions was kind of a beast. Remember, that's the one that used the pooled proportions down here. If we put the corresponding percentages in there, we are going to get the actual z-score or critical value of negative 3.339, which is what they got with their calculator. If we compute the p-value for that, it's a two-sided test. So remember, on this confidence interval, if I were to sketch it, this is the negative 3.33. If I find this, which I'm doing right here, negative 999 to negative 3.339, this has been standardized, so use 0 and 1. It's a two-sided test, so we are going to have to do the other tail. That's why they came in and multiplied it by 2. And therefore, again, we get the same p-value, and we're going to make the exact same conclusion. Feel free to use any method if it's a test of homogeneity with just 2 treatments. If you want to use the 2-sample test instead, you could.